Hello, pre-algebra students. Today we're actually working on section 2.3. We're going to take what we've learned about distribution, we're going to distribute, and then we're going to collect our like terms. We're actually going to make our variable expression simpler than it looks after we've done the distribution. We've got a little bit of vocab to go through first. This is right here on your page. This is the expression that we're looking at. I don't know why I always start off kind of wiggly. Here's the expression that we're looking at, 5x minus 4x plus 7. If we're looking at an expression like this, the terms are actually the pieces of the expression that are separated by addition and subtraction signs. So 5x is a term, and then the next piece is negative 4x. The negative goes with the 4x, and then positive 7. There are three terms in this expression, and they are 5x, negative 4x, and 7. The coefficients are the numbers in front of the variables. So I see two variable terms in this particular expression. See, I can highlight them. Here's a coefficient, and here's a coefficient. I see 5x, the number in front of 5x is 5. I see negative 4x, the number in front of that term is negative 4. The sign goes with the 4. The constant terms, you might think about what the word constant means to you. To me, it means something doesn't change. If it's always constant, it stays the same. Well, the constant terms in a variable expression are the numbers that don't have variables attached to them. So in this case, positive 7 is our constant. The like terms are the terms that we can actually combine together. They are the terms that have the same variable and same exponent. And then all numbers are like terms. So in this particular expression, we see a 5x and a negative 4x. They have the same base, x, and they have the same exponent because these are actually to the ghostly 1 power. So they meet our criteria. They have the same base and the same exponent, so we can actually combine those guys. So if you have 5x's and you take 4x's away, you end up with 1x plus 7. So let's fill out this next piece. Here are two rules. To simplify an algebraic expression, you look at your pieces. A variable expression is simplified if it, number one, has no, let me back this up a minute and erase this and start over. I was getting ahead of myself a little bit. So an algebraic is considered to be simplified if it has no grouping symbols. In other words, you've gotten all your distribution done. Has no grouping symbols, and all like terms have been combined. So in our example up above, we didn't quite finish combining our like terms. Our 5x minus 4x leaves us 1x plus 7. There's no grouping symbols, and our like terms have been combined. You cannot add 1x and 7 because 7 doesn't have an x next to it. These are like apples and oranges. They're two different things. Or you could just say x plus 7 because we don't have to write the ghostly 1 in front of him. So to simplify expressions, you distribute if necessary. How do you know if you have to distribute? You look for grouping symbol, which usually is a parentheses. Generally, it's a parentheses. Once the parentheses are gone, then we look for like terms. Terms are considered to be like terms if they have identical bases and exponents. And all numbers are considered to be like terms. So for instance, x and x squared are not like terms. They have similar bases, but their exponents are different. He's to the 2 power. This guy is to the ghostly 1 power. They are not considered like terms. Okay, let's do a couple examples. So I'm going to identify the terms for this expression right here. They are going to be the pieces that are separated by the plus and minus signs. Positive 6a, positive 3, negative 5, the sign goes with the 5, and a positive 4a. Those are all the terms. There are 4 of them. The like terms are the numbers. They're like terms, and the a's are like terms. Those are the guys we can combine. Coefficients are the numbers in front of the variables. They do not include the variable, so we have a positive 6 for that guy and a positive 4 for the number in front of that guy. The constants, remember we said those are the numbers. They remain constant no matter what value we plug in for a. The 3 stays a 3, and the negative 5 stays a negative 5. So to simplify this expression, we combine our like terms. A positive 3 and a negative 5 is a negative 2. A positive 6a and a positive 4a is a positive 10a. Now you might have written this 10a minus 2, and that's perfectly fine. Which property do you think says that we can write that either way? I say it's the commutative property of addition. Okay, let's do a few, and then I'm going to have you do some on your own. The first thing we look for is distribution. I see parentheses, I see distribution. I'm going to bring this 4x down just like he is. I'm going to distribute my positive 3 and get positive 3x, and then positive 3 times positive 1 is positive 3. Now I have to simplify. Just like you don't walk around saying you're 10 plus 2 years old, you're 12 years old, I'm not going to walk around saying I've got 4x plus 3x. I have 7x plus 3. Let's do number 3 together. I see distribution. I'm going to bring the negative 4 down. I'm going to write this as 12s. A positive 6 times a negative 9 is a negative 54. Now, all I see that I can combine are some numbers. I've got a negative 54 and a negative 4. That combines to negative 58 plus 12s. And now I'm finished with that problem. Okay, here we have one that's got the ghostly 1. You can't see him, but you know he's there. So let's go ahead and draw him in right here. So we'll know we have to do our distribution with the ghostly 1. Distribute, minus 1w, minus 8, because a minus 1 times a positive 8 is a minus 8. Bring down the rest of the problem. And now we're looking for like terms. I see w to the first power and w to the first power. I can combine those. I've got one of those w's over here, negative 1 of them, and negative 16 more. That makes negative 17 of those w's. And now my numbers combine. I have a negative 8 and a positive 7. That's a negative 1. Now I want you guys to go ahead and do number 7 on your own. You can pause the video and work it right now, and we'll talk about it in class. I want to skip down. Now we have some that are essentially just what we've done before, but I'm using a variable to the second power instead of the first. They're still like terms. You still have to distribute. If you look at number 9, there's actually going to be 2 distributions that go on before you can collect like terms. These can get pretty complicated, but they're really fun. So let's look at the first one, number 8, and then I'll ask you to do number 9 on your own. 72, 9 times 8, minus 54v squared, minus 12v to the second power, plus 20. I'm looking at my like terms. I have bases of v, both of them with exponents of 2. That's a good thing. I can combine them. So if I've got negative 54 of them, and I have 12 more negatives of them, I have negative 66 of those v squares. And now I combine my numbers. A positive 72 and a positive 20 makes a positive 92. You guys try number 9. We've got one last little back page to look at. Of course, we're going to do some area perimeter. You know we're going to do that all year. They want us to do both the perimeter and area. I'll do the rectangle, and I'm going to leave the triangle for you for homework. Let's start with area. Formula first. Shell second. Plug it in. Third, we have the length is 4x minus 6. The width is 3. Now I see distribution. I'm going to distribute the 3 to both of those pieces, and I get 12x minus 18. That looks pretty good. And I'll leave the formula, or leave the area of the triangle for you, but let me go ahead and do perimeter of our rectangle. Formula, shell, sub it in, 4x minus 6, and I think that width was 3. Yep. So now we've got distribution. We're going to distribute, and we get 8x minus 12 plus 6. We're almost finished. We have to combine our like terms. We've got some numbers that go together, and we end up with 8x minus 6 units as our final answer for perimeter. So you guys do the area and perimeter of the triangle, and I will see you in class with any questions you have. Bye.